Okay, in this video, we will look at identifying linear and exponential functions, and we'll try to identify them based on a table of data of xy values. Now, a linear function, for a linear function, the y values will have a common difference. That is, changes that are made to the y values will be done by addition or subtraction using the same number each time. For exponential functions, the y values will have a common ratio, not difference, ratio, which means the changes made to the y value will be by multiplication or division, again, of the same number each time. So if we take a look at this grouping, we see the x values 0, 1, 2, 3, 4, and notice the y values. To go from 1, 0, 3, 6, 9, 12, to go from one y value to the next, we see plus 3, and to go to the next value, plus 3, to go to the next value, plus 3, and the last value, plus 3. So we see that the y values are created, that is, they have a common difference, plus 3 to get to the next y value. So this group of data would represent a linear function. Let's take a look at this next one. Again, we have x, 0, 1, 2, 3, 4. Y values, negative 1, negative 3, negative 9, negative 27, negative 81. Now, to go from negative 1 to negative 3, just using addition or subtraction, we would subtract 2. To go from negative 3 to negative 9, we would have to subtract 6. So we see immediately there is not a common difference. We are not using addition or subtraction of the same value to move from one y value to the next. So let's try multiplication, and of course we see that to go from negative 1 to negative 3, we would multiply by 3. From negative 3 to negative 9, we would multiply by 3, and so forth. From negative 9 to negative 27, we would multiply by 3, and to get to negative 81, we would multiply by 3. So we do see a common ratio. That is, each of these y values is created by multiplication, specifically multiplying by 3. So this set of points, these xy values, represent an exponential function. Let's look at one more example. Again, here are our xy values. And to go from 80 to 40 with the y values, we'd have to subtract 40. But to go from 40 to 20, we'd have to subtract 20. So we notice there is not going to be a common difference. We're not going to create these y values using addition or subtraction. So let's try multiplication or division. Well, we know that 40 is half of 80, so we could write that as times 1/2 to go from 80 to 40. And then to go from 40 to 20, we see that would also be times 1/2. And of course, to go from 20 to 10, times 1/2. From 10 to 5, the same, times 1/2. And we notice we have a common ratio. They are all, to move from one y value to the next, we are multiplying by 1/2 each time. And since we use multiplication or division, this is an exponential function. This data, these data points, xy points, represent an exponential function.